This is limits of piecewise functions. So again, we have to do left and right to see if our limit exists. So how you want to do piecewise functions is you want to think about it this way. Coming in from the left and to the right, we're always going to be asking for that limit at that value of where they connect. So if coming in from the left and the right, it's the same value, you're good, you got a limit. But if coming in from the left and coming in from the right, it's not the same value, you're not going to have a limit. You will always have a left and you will have a right, but you may not have that limit in the middle. So let's look at it from the left. So coming in from the left, this is 2 from the left. That means that our x's here have to be less than 2 if we're coming in from the left. And so that would be the first one. This right here is our limit as x approaches 2 from the left because it's less than 2. You're going to be plugging in numbers like this. Give me a number less than 2. 0. Another number less than 2. 1. And then you still want to plug in 2 because you want to see, do they connect? So we're just looking, do they connect? Okay? So if we plug in 0, we're going to be using this. So the limit as x approaches 2 from the left, we would be using 3x minus 5. Because for values less than 2, our function is equal to 3x minus 5. So now we're just going to plug in 0 and see what we get. So 3 times 0 minus 5 is negative 5. We're going to plug in 1. And that's negative 2. And then we're going to plug in 2. And that equals 1. So coming in from the left, we know our graph is going to approach 1. It's doing this. We're going from negative 5 to negative 2 to 1. So it's doing this coming in. So this would be 2, 1. Now we want to see the other side. So now coming in from the right, that's this one, x is greater than 2. This is x approaches 2 from the positive side. So we would be using x squared minus 3 for this one. Oops, completely forgot the limit. That's not good. Limit as x approaches 2 positive of x squared minus 3. So now we're going to do the same exact thing. We're going to plug in numbers coming in from the right. So give me something bigger than 2. So 4, 3, and 2. We're coming in from the right. So if I were to plug in 4, that would be 16 minus 3, which is 13. And that would be 9 minus 3, which is 6. And then that would be 4 minus 3, which is 1. So as we approach from the left, we are approaching 1. Right here. And as we approach from the right, it is our parabola, right? We are also approaching 1. So we know that the limit from the left and the limit from the right are both 1. And so you can also look at this graphically. So you can see here, coming in from the left, we are approaching 1. Coming in from the right, we're approaching 1. So you can really just plug in that number to see what you have here and make sure that it connects to the same point. Does that point have to be part of it? No. So from the left, from the right, we approach 1. And so from the left it's 1, right is 1, so that means our limit here is 1. And then the other part of this is to see, is it continuous? So that equal sign does fill it in. So we know it looks like this, and the equal sign on the 3x minus 5 fills that in, that little hole, which means our function is continuous. So yes. So when you're doing piecewise, you want to look at it from the left and from the right. So the left is this function, and you could just plug in 2 and get 1, and you plug in 2 and get 1. And there you have it.